Hey guys, welcome to example 2 of 9.3. We're looking at defining a sequence recursively, and I forgot to mention that sequences in series, this section, it does help for students to be exposed to this also, not just for math, because if you go into pure math with real analysis, if you become a math major, you'll do a lot of discrete mathematics with a lot of proofs. You do sequences in series, of course, in parts of calculus, especially the C part of the BC, but with recursion, we do touch upon this in computer science. And one thing that's slightly different in computer science is that the sequence of, 1, 2, 3, 4, 5, computer science tends to start at 0. When we do data structures, the first index is always 0, and hence some of the stuff that you're doing here would actually help you kind of start getting into the mode of thinking that's required for data structures in computer science. So just keep that in mind if you are somebody who's going to take computer science in the future or look at it in the future. All right, so example 2, defining a sequence recursively. Find the first 6 terms and the 100th term for the sequence defined recursively by the conditions. And here what we have, b sub 1 is equal to 3. This is what's known as a base case or initial condition. Or actually, it's a base case. Initial condition is a little bit different for calculus. And the recursive definition's right over here. B sub n is equal to b sub n minus 1 plus 2 for all n greater than 1. And what this basically means is if I want the current number, so I would say this is the current number, right? If I'm interested in that number, what I need is the previous number in the sequence, right? Because b sub n, if that's 100, then I would need b sub 99, right? So this definition is a recursive definition, and it's rather simple because it's just saying that, hey, if I want the current number, I just need the previous number and add 2 to it. And so, and this needs to be for all n greater than 1, because obviously if you are 1, you don't want to say, oh, well, which is the 0th term, right? That'll actually make more sense in computer science because we start with 0, but over here, we want to go all definitions for n greater than 1 because b sub 1 is 3, right? If you didn't have that base case, then you would just keep going, right? Like, well, it's 2 more than the previous number. At some point, the previous number will be the first number. But if you don't have the first number, then you don't have, you can't figure out what that sequence is recursively. So let me show you. If I want the first 6 terms, this is rather easy because we already know that, well, it's just a previous number plus 2. So if b sub 1 is 3, so we can just write that. Then the next number would just be b sub 1. Well, that's just 5, right? Because it's just 3 plus 2. And of course, if you just keep adding 2, right, it becomes pretty easy. Or it is, and I still make a mistake. Go figure. All right, so b sub 5 would be 11, and then b sub 6 would be 13. If they want b sub 100, that's kind of tricky if you were to write it all out. But what you could think about, there's 2 different ways I was thinking about this. Okay, if you look at the textbook, they'll say, well, hey, what did you do to each one of these after the base case, right? And basically, you added 2. So how many times did you add 2? You added it, I believe, 99 times, right? Because if you get to 100, you have, right, you didn't add anything at the first one, but after that, you kept adding 2. So how many 2s did you add? You added 99 of them to get to 100. So you can think about it that way. Another way you can think about it is, you kind of did this a lot in the math that you learned along the way to take MCAS tests, right, with math. You did a lot of sequences there where you have to look at patterns. And so how does a 2 become a 5, a 3 become a 7, a 4 become a 9? Another way you can think about it is that, hey, if I just double the k and add 1, right, that's another way to think about it. So that would just be double the k. So I can also define this explicitly. So this is an explicit definition, right? It would be, let me write write definition. That would be b sub n is equal to 2n plus 1, right? If I double n and add 1. So that's another way you can approach this. So you can figure it out intuitively, or you can try to figure out the explicit definition. So that would be, again, 201, right? Again, you can think about it as 3 plus, right? Because you started with 3. You can do 3 plus 99 times 2, or you can figure out the explicit definition. Either way, nothing too bad.